code. How do you think we do that? We need to eliminate dependencies between the native world on the managed world. How do we do that? I didn't hear DIP. Dependency Inversion Principle. Have you forgotten already? DIP. That means there will be object factory and interface. Now, so Amar did a little bit, as you know, very well crafted, nice demo. Let me pull it up here and we'll run it for you. You know, and his GUI is doing a little more than I wanted it to do. Okay, he's doing a little, you know, but there's no real COM system here at all. No COM. Okay, just mock stuff. Okay, so. And it's worth looking at, you know, because especially, you know, you can take a look at his GUI and see how he's laid out stuff. I'm gonna, though, I want to take a little bit of a look at some of those details. As they say, the devil is in the details. So, you know, when we start adding all this stuff in, the real COM, the real server, there's some details to take care of. So I'm working on right now, this is not quite complete. This code is on in Project 3 Help Spring 18, but I would recommend that you don't look at it quite yet, because my intent is to finish this up by late tomorrow if I can. So, so for example, let's, I've got a GUI that, you know, useful for browsing maybe. Whoops, useful for browsing maybe. Now, at this point in time, what my demo does is, my demo has a prototype server that's processing messages. It's using COM. And I have a C++ CLI shim, which is, I think, all that you need. This guy is a translator, and I've called it Translator. So this guy is going to generate messages, and he needs to post them and get them. That's really all he needs to do. This guy needs to translate things like endpoints and messages from the managed world into the native world. A managed string is not a native string. Managed message is not a native message. They're very close, because I designed them both to be close, but they're not the same. So this guy has to translate between them. And I don't think you need to do anything more than what's already here. I don't think you need to do any more than what's already here. You need to work on these two ends. So you need to add a little bit of functionality, and then add some processing down here to handle that functionality, add some functionality, add some processing here. And I'm going to show you that maybe that isn't so very, you know, I've tried to organize it so that that's eminently doable. So because I have it, so we already ran the GUI. So now let's take a look at the server. So I have a little server prototype. First of all, let's look at the pieces. So I have a client. I have a C++ CLI translator. I have a communication system which is using messages and sockets. And I have a server that's using the file system. Okay? That's what all these parts are. And a little wrapper that I'll talk about in a minute. Not in a minute. I'll talk about before the end of the class. Okay? So those are the parts. And they correspond very closely to that diagram. Okay? Translator, GUI, server prototype, message passing communication system. Okay, let's take a look at the server end of things. So let's look at the server. So what's here in the server end? Now, you know, I don't have comments here and stuff. There's lots of stuff that this is a work in progress, so bear with me. But I have a class server that talks to the communication system. It has a COM, and so this start and stop just starts and stop. It's COM. Okay? Just like, you know, the test stub on COM does. I have a function that processes messages on its own thread. And those, and down here, there is a dispatcher. So let's see what that dispatcher is. If you go up here and look at it, you will see message dispatcher equals standard unordered map of key and server proc. So the model is, in comes a message when some attribute in the message has a key, and that will trigger a server proc callable object to run. So you want to add a little functionality? Generate a message with a new key, generate a server proc to handle that message. Done deed. Don't have to tear anything apart. Piece of cake. Notice that the server proc is a callable object that accepts a message and returns a message. This is the message that's going to get him to do something, and this is his reply message. So the process messages is just sitting there, getting messages out of its queue, calling, looking for that key, dispatching the message to its processing, getting the return result, sending it back. Piece of cake. Piece of cake. So it has a start stop and post message, and process message is where it's get messages, where it's calling get message. Okay. It has functions get dirs and get files that is just going to use the file system. So you give it a path and it comes, you know, hey, that's a fundamental part of, and that's all I'm going to do. I'm not going to do any more, you know, there's lots of other stuff the server has to do, but that's what I'm going to do. So my intent is to so where I am is I'm just about to couple this into the server proc. This end, the client end, has created a communication. It's got a comm system. Okay, I just haven't started it. Right after class, if I don't get a lot of people knocking on my door, I'm going to start it, okay, and start sending messages back and forth from the client. And the model is, I got get files and get dirs, and guess what? It's going to get populated in here. Now, why do that? So, think about check-in. Check-in has to provide a file and some metadata to the server, and our mental model is then it's got to go set a whole bunch of relationships. Those relationships require browsing to click, 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 click. So I wouldn't set the relationships in my check-in. My check-in would set the metadata and get the file transferred, and then you go over to browse and you click, 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 and set the relationships. That's my mental model. Okay? Single responsibility principle. You know, you could put the same browse view right in your check-in, but why do that? It's already there in browse. Why duplicate it? So what I am doing is I won't even set the relationships. All I'm going to do is get the basic browse working and then turn it over to you. But my mental model is that maybe down this row you have some checkboxes. And so you go to the directory you want, and here's some files I want to add as relationships. So I just check that checkbox, check that checkbox, check that checkbox. And as soon as I check the checkbox, it gets added into the relationship data in the NoSQL database. Okay, with a query. I'm not going to do that for you, but that's my mental model. Okay, so anyway, so now let's go back to the server. Let's look at that a little more. So in fact, let's set it as startup, and I'll run it in a minute. But so we've got this dispatcher, and let's see how some of that works. Let's go look at add message proc. Let's just go to the CPP file. So here's the get files and get dirs, just using the file system and a show function. And now here is one of my server procs. So standard function message echo equals message return message. You send me a message, I'm just going to send it right back to you. Echo, 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 echo. Okay. So, and now here is get files. So here I expect my message has a command. So command is just an attribute. It's the key. Command is the key. And I have a command function, which returns that key. It returns the value of that key. So I have a key, get files, and so I am setting, so I'm building a reply. But so basically, when this message comes in, its command, if I call its command will be get files. And so get files is my key. So I'm going to say, here I am setting up, I'm going to build my reply message. So my reply to is the incoming messages from, the reply from is the incoming message to. Just swap the addresses. And I'm going to give him the same command as this message had, just so that the responder knows that this is a response to the get files request. And then as long as the, so string path equals message.value path, so I expect the message to have an attribute whose key is path. And his value is something like .. storage or .. storage / test1 or something, whatever the path is. Okay, and that path is determined by what you clicked on the client. Okay, and now server get files from that path, blah 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 blah. Okay, and now I am going to add attributes. File, so here I have a counter as I'm counting these files it found, file 1, file 2, file 3, file 4. And they're going in file 1, file name, file 2, file name, file 3, file name. They're just attributes in the message. I could have created an XML and put it in the body, but why do that? Attributes are so easy to use. So now, and here's a, get dirs does exactly the same thing. Now let's look at main. No, let's look at process messages. No, just, get rid of this. Goodbye. Where's my get messages function? Did I put it in the... There it is. So here's my process messages. Server process messages. So I'm creating a thread. And if my dispatcher size is 0, it says you haven't stored any procs for me to process, so return. But otherwise, I get a message. If command equals server quit, I break. But as long as it isn't server break, message reply equals dispatcher message.command message. Remember, message in, message out. That's what this proc does. So this dispatcher takes a key, and then this is executing its value with the incoming message. Its value is a server proc. So if this key is echo, this is gonna execute the echo method. If its key is get files, it's going to execute the get files method. Okay, and you say, but I want another one. You just go add proc. Add server proc, you got to know whatever you want, okay? So now, if message to port is not equal to message from port, post the message. Now, in my little test stub, I send a message to myself in the test stub for the server, okay? And the first time I ran it, I didn't have this test, and guess what happened? I got this message, I echoed it back, okay? Which I was echoing it back to myself because the to and from address. So I get the message and I echo it back. I get the message and echo it back. Echo, 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 echo. Infinite loop. Okay. So if I am sending it to myself, I just show the message. But if I'm not sending it to myself, I post it back to whoever sent it. Whatever that reply is. If it's an echo, it's just the same message you sent me. But if it's a get files, it's a get files message. So let's run it and see how it works. It is set up. Okay, so let's run it. So here, I'm testing the get files method. I'm testing the get ders method. Now, starting server thread to process message, posting message echo, getting message echo, localhost 8080 from localhost 8080, name message to self, command is echo, posting, command get files, file 1, system.cpp, file 2, system.h. And on the client end, what I'm going to do is I'm going to look through the attributes on the client end for strings that start with file in the key, in the attribute part, in the key of the attribute, and grab the path and insert that path from the value and insert that in the list box. Piece of cake. Okay. Now, so that's the server, and so there isn't a whole bunch of processing there, but it's really easy to extend it. You want to extend it? Add any, helper functions you need, and then add a server proc. Okay, design the message. So it's really, the process of extending this is really define the message, define the processing, turn it loose. Okay. Yeah.
Could you please show the get message method?
Go to what?
Get message method which you invoked in line number 91.
Right.
Can you show the definition? Can you show its definition?
Yeah. It's just from COM.
Okay.
It's all I'm doing is this is my COM. So all I'm doing is directly delegating. I mean, let's do it, but here's get message, com get message. I'm printing out that I'm getting the message, and I return the message. Okay, I'm just using com. That's all it's doing. Okay, let's go look at Translator. Now, let's look at it first. So I want to come back. Don't let me forget, I want to come back and talk about the references in a minute. But so this translator's job is to translate messages from the managed world to the native world and back again. Remember, all we got is a client that's sending and receiving messages. That's all it's doing. And so what is this guy? And this guy is sending and receiving messages. This is sending and receiving native messages. This is sending and receiving managed messages. So all this guy's got to do is translate those messages. Now, a managed string is not a native string. A managed int is a native int. A managed double is a native double. But a managed string is not a native string. I got to translate it. And a message is a whole series of attributes, and attributes each have a string key, string value, so I got to translate. That's all I'm doing. So let's look at that translation. So first of all, there's a CS message class. So now if you remember, our message class is nothing but a set of attributes. Really. The native message is just a set of attributes. You know, you say, oh, that's not true. It's got a body. Our messages look like this. If you look carefully at my COM system, including file transfer, you'll see that none of my messages ever holds this body. If I want to send a file and a message in chunks, I could put a body, I could read a block out of the file into the message body, and then read it out of the body into the socket. Why use the middleman? Why not just read it out of the file right into the socket? So this is a virtual body. Okay? So there's a content length, and this just tells the socket, now I'm going to give you this many more bytes. And so I've got, put in the header, grab a block out of the file, put in that block. Grab a header, grab a block, put it in. That's the way it works. Okay? So really, the native message is just a bunch of attributes. And guess what? On the CS side, it's exactly the same thing. So first of all, before we get to that, remember this is a translator, so I have a class that has two methods, managed to native string and native to managed string. Just string conversion. Now, what's this flaky ref? And what's this fancy hat? So C++ CLI, you can define both native classes and managed classes. How do you tell the difference? Native classes are just like always, class, blah. Managed classes are, guess what? Ref, class, blah. So this says, this is a managed class. Guess what? It's a reference type. Managed types are all reference types. They have a handle that points to a body, an instance on the heap. Now, in C#, if we have a string member of our class, we say string, my string. That's a lie. the code has said this is a string type. But what's over here, my string, is not a string type. It is the type of a handle to a string on the native heap. Managed C++ says, we're not going to lie to you. We're going to tell you in the spirit of C++ exactly what the code is doing. So this hat says this is a handle to a string on the native heap, on the managed heap. Okay? C++ CLI has both a native heap and a managed heap. You get to the native heap by calling new, just like always. You get to the managed heap by calling GC new, garbage collected new. Okay, so and now the methods are pretty straightforward. So here, managed to native string. So in comes a managed handle to a string, and now I'm creating an instance of a temporary string for I equals 0, I less than this managed string's length. So a native string you call size function. This is a property. Managed code has properties. They're really get set functions, but that are hidden from you. Okay, it looks like public data, but it really isn't. It's get set functions. And now temp, the string, push back. So now this managed string is a collection of 16-bit characters, Unicode characters. And I've got to convert them to 8-bit characters, and I do that with this cast. And that works just fine. So I just built a native string out of that managed string. And for going the other way, native to managed, in comes my native string. Now, I use a string builder. This is a managed class to build the string. Just like Java, C# and C++ CLI strings are immutable. And so every time you add something to them, you create a new object, create a new object, create a... So string builders don't do that. String builders are not immutable, and you can add to them. So typically, so string builder, SB, so this is a, SB is a handle to a string builder object on this managed heap, GC new. Okay? So for auto ch char in string, string builder, append, wide char. So now I'm casting this 8-bit char to a 16-bit char. Return. Bam. Piece of cake. Okay. Now I have an endpoint. Just like in my native code, in my message class, I had an endpoint class. And so there's a ref class, a CS endpoint. This stands for C# because it's the C# client that's going to use it. So I called it CS. Even though it really isn't, it's C++ CLI, so maybe I'm lying to you, but anyway. So the constructor automatically creates an endpoint. So this class holds a machine address and a port, and so this endpoint is just creating an empty string and a port of 0 by default. And I have a toString and FromString functions, so this endpoint is really like a struct. It's a class, but it's like a struct. It's a string and a port integer. Now, to convert that to a string, I take the string, add a colon, and then I add the integer converted to a string. And coming back, I parse out the string, the colon, the int. So, you know, and you can look at that. You know, it's all here. Allow me to, you know, here I am, you know, toString, you know, machine address plus quote, port.toString, and, you know, from string is doing a little bit of parsing, you know, system convert to int32 port string, blah, 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 blah. You can look at it. So now, here's my reference message class, CS message. Now, this message has attributes. If you go up here to the, inside this namespace, The attributes is a dictionary of string. Key and value. Each attribute has a key and value. Okay? And so here's the message class. It has an attributes property. Okay. And again, notice this is a hat. So this says attributes is a handle pointing to a dictionary of string on the managed heap. Okay. And I have functions. I have a constructor that just creates an empty attributes container. And I have a constructor that takes a to and a from endpoint, and I construct the attributes, and now I add, attributes add to machine address plus colon plus to port string from machine address plus colon from port string. Okay. In general, my add function accepts a key and a value, and it creates an attribute. I have a add function for my attributes type that just adds a key and a value. And I can get the value back by feeding it a key, value, okay, that gives me the return attributes of key. So, you know, piece of cake. Here's the show function. Now, show, the iteration is done a little differently in managed code than it is in native code. It uses an enumerator, and so I say attributes, give me your enumerator. An enumerator is something that can move to the next one and give you the current value. And by the way, when you step off the end of the container, move next returns false, just so that this kind of loop works. Okay, so you know. I'm stepping over the enumerator. I say key equal enumerator dot current dot key, value equal enumerator dot current dot value, and I display them. Okay, so let's look at that CS message. Here's Translator. So, rough class Translator. Translator has a listen function that creates an instance of com for itself. Now, com is a native object, so it will be created on the native heap. And it has a post message function, a get message function, and a translator that takes a native message and turns it into a managed message. And it has a from CS message, accepts a managed message and turns it into a native message. Just exactly what you need. Okay. So, and now it holds an endpoint. This is the endpoint it's going to listen on, and it holds a factory to create the communication system, and that factory returns a pointer to an icon. So it's this object factory and interface that separates out the all of the native condition variables and mutexes and stuff that managed code can't digest, hides it behind the interface, and now the managed code just uses the interface, the factory, over there, go create this object so I can talk to it, and then it talks to it through that interface. Dependency inversion principle at work. Aren't you glad we talked about the dependency inversion principle? Because you know exactly what that means. Object factory and interface. So my default constructor for the translator just creates an endpoint on the native heap, and this is just going to be an endpoint with 0 port and empty machine address right now. And now my listen function, what this does is, right now, what this does is, you tell it what endpoint you want to listen on. So it says, okay, my endpoint machine address is that endpoint's machine address. My endpoint port is that endpoint port. So I'm setting up my listener. Now I say factory equals new com factory. Okay. This is a native class. The com factory is a native class. So I say new because I'm creating an instance on the heap. Managed ref classes can hold native pointers as well as holding managed pointers. And now I say, this is going to return, this factory is going to return me a pcom, and the factory has a static method called create, and I give it the machine address and the port. Okay, my machine address. So what this is doing is, this is creating a native com listening on the port that I told it to listen to there. The one thing I haven't done yet is I haven't started that com. That's the next thing. When I walk out of this classroom this morning, if I don't have a stream of students knocking on my door, the next thing I'm going to do is add pcom arrow start. I'm going to start sending messages back and forth. Okay. And now, from message, guess what? So here's my translation from native messages to managed messages. So I create a new managed message, and then message attributes equal message.attributes. I'm just grabbing the attributes. For auto attrib in attribs, CS add attrib.first is a native string, so I got to convert that to a managed string for my CS message. And SU utilities attribute second is a string value for that attribute, and so I say native to managed again. Okay, and now I do that for all the attributes, and I'm done. Because a message is nothing but a collection of attributes. A native message is nothing but a collection of attributes. A CS message is nothing but a collection of attributes. And all I did was translate one into the other. Blip, 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 done. Piece of cake. And from CS message, here we go, getting the enumerator again. So here, auto enum, blah, 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 get enumerator, enum.move next, blip. Done. So now I've translated, I can translate my messages back and forth. Post message, what do? Post message says, this is the message I want to post. This is a managed message. I got to convert it. Before I post it to my native channel, I got to convert it to a native message. So message equals this from CS message. It's now a native message. And now I say pcom post message. Now, I haven't started it yet, so it'll go there into the queue, but it won't go anywhere because I haven't started the send thread and I haven't started the receive thread. That's what I'm going to do 10 minutes after class is over if nobody knocks on my door. And get message, just the other way around, get message. So, and let's look at translator.cpp. So I'm going to test it. I'm going to test the endpoint. I'm going to test the message. And now I'm going to say tran listen at this endpoint, tran post message, and tran get message. This will post a message to the queue, but no, there's no sed thread running yet because I haven't started its COM. And when I call get, it's going to sit there blocked on an empty queue because there's no message coming. But, 10 minutes after class is over, it'll have a message there. So let's run it. I'll tell you what that beep was in a minute. So, testing CS endpoint, sure enough, that looks like an endpoint. Testing CS message, sure enough, that looks like a message. Testing translator access to COM. So I'm creating the instance of COM on the native heap, and I've looked at the debugger, and I'm sure that I got a pointer to it, and I can look at that pointer, and it has all the methods that it should have for the COM interface. Now, but I didn't. The only thing I didn't start it, so nothing happens here. This just blocks. But as soon as I start it, messages will start to flow. So that's the test stub for Translator, and the GUI now will simply, once I'm sure that Translator is sending the messages back and forth and everything is hunky-dory, which I think will take about 15 minutes. Then I will add a little bit of handling in the client GUI to go get, a button that says get files, and a button that, a little bit of clicking that'll allow me, I'll double click on a directory and that'll pop me down into the directory and show me the new files in the directory. That, a little bit of, it's just going to use that get files and get DIRs processing that's already in place in that server prototype. Okay, that I showed you here in server prototype. If all goes well, doesn't always, but if all goes well, sometime tomorrow, probably late tomorrow, I will post it on the completed working prototype. I will post on Project 3 Help Spring 18. Okay? Right now it's there, but in this, very few comments and not starting COM yet and stuff like that, but just on the verge. So sometime Wednesday, when I've cleaned it up a little bit and it's now suitably attired, okay, for formal presentation at the prom, okay, I'll post it. And that's probably the last thing I'll do. So let's go back here and look at this guy again. Whoops. Let's look at this guy again. So the prototype will have just a little navigation and enough over here to support that navigation. And now you'll need to add, I don't have tabs here, by the way, and Amar's demo, okay, Amar did a little demo. I showed you Amar's demo, didn't I, at the beginning of class? Yep. So Amar's demo had, he had tabs and, all that sort of stuff. And so look at that, and you can see how to add that kind of stuff here pretty simply. So I think your job here is to add some functionality, add some processing over here, and work your way toward Project 4. Let's go look at the Project 3 requirements. Oops, wrong thing. Okay, let's go to Project 3. So it says, yeah, we'll use 2017, blah, 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 blah. Done deed. Shall provide an asynchronous message passing communication channel used for all communication between clients and a remote repository server. Channel will use HTTP style messages for sending requests, receiving replies, and transferring files between clients and server. Guess what? You're already done with that. Good for you. Pat yourself on the back. You don't have to do anything. That's done. And you say, but we're not sending HTTP messages. We're not sending HTTP messages. We are sending HTTP style. Attribute, 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 attribute. Okay? So you don't have to do anything additional to satisfy that requirement. 3, shall provide a client graphical user interface that supports tabs for the views, blah, 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 blah. And if you just grabbed a Mars, you'd say, I've satisfied all the requirements. So what does that mean? Suppose that you just took my code and a Mars code and wrapped it up and sent it in. What happens? Well, guess what? You get 25 points for requirements. For reusable modules, you get 0. You didn't create any. For runs reliably, you get 0 because nothing you wrote runs. For compiles and links, you get 0 because nothing you wrote compiles and links. You get 0, 0, 0, 0, 0. So guess what? You got 25, which is about what you should get for submitting our code. Back to us again, okay? It says at least you submitted something, but okay. So now there's a lot of freedom in what you do. What we want to see is some progress toward Project 4. The more progress you make, the easier it will be for you for Project 4. So I think, let's think about what you got to do. So you can take my prototype project, as soon as I get it to a fairly decent stage of completion sometime tomorrow, with the comments and stuff, so it's really readable. You need to add some functionality for new messages. You need to design messages. So here, in this handout, Project 2 design starts at page 16. Check-in tasks. Task, 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 task. And I think you'll find, if you look at them carefully, that there's probably a bunch of messages you're going to send. Not one to do check-in, but maybe something close to one message per task. Maybe not, but close to it. That's really, what I was telling you, when you're going to set the responsibilities, you'll come over here and click, 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 click. And so, there's 3 or 4 different kinds of messages. You'll be doing get files, get ders, and then check, 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 respond in an event handler to those checks that add stuff into the responsibility metadata. So I think what you need to do, guys, can we have one conversation, please? I think what you need to do is, so we're going to use the Agile method. We have a core. Now we're going to do some layers on the core. So our first sprint will be to add a little bit of functionality. So add a server proc on the server end. Design the message. Think about so you design. You think about the tasks, you design a message, design a server proc. Let's say there's 3 messages for that big task. Design the message, design a server proc, design a message, design a server proc, design a message, design a server proc, and have a function that, creates those 3 messages, sends them, gets whatever to happen. Sprint 1. Sprint 2, next task, plop, 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 okay? So you're going to wind up making some progress toward Project 4. And the more progress you make, the better, the easier it is for Project 4, for you in Project 4. So we're going to be quite forgiving on how much you actually do technically in Project 3. You know, you'll get chopped off at the knees if you just wrap up the code and, you know, our code and submit it back to us. You'll get a 25, guaranteed. But that will grow very quickly from there. And we will be generous because A, you got to get your arms wrapped around WPF. I got to figure out enough about WPF so I can add that functionality to WPF. And that's what we're going to talk about on Thursday. We'll take a quick look at whatever I've done on this, and then we'll look at WPF. And you've got to look at C++ CLI enough so that you understand what the translator is doing. I don't think you have to change the translator at all. Okay. And you'll need to look at the wrapper. I want to talk about the wrapper just a little bit before I meant to do that and I forgot, but let me go back to that. You'll notice that there is a library wrapper. So what's going on here is all of this I built is one DLL. This is a native DLL. And this is a managed DLL that uses this native DLL. And C#, and this has to be created as a DLL. That's the only way C# can interact with it. C#, when it's compiled, will load that, when you start it up, will load that managed DLL and interact with the managed DLL just fine. And the managed DLL, because it's written in C++ CLI, can interact with the native DLL. So there's one thing that distinguishes managed DLLs from native DLLs. So managed DLLs, all you do is you go to the project setting and you click on DLL. You take application.exe and turn it into library DLL. That's not true for native. Native DLLs, you need a little bit of decoration. Let me show you, and then let's just show you first. So let's go look at the COM library wrapper. So here's this ICOM interface. So this is the interface for COM. I don't know that I showed you, but this is static, create function. And after down in this the COM file where once I've declared the COM, and COM now derives from ICOM. Once I've declared DOM, I create this. I implement this create method, and all these other methods just delegate down to COM. Okay. Just COM implements start, COM implements stop, COM implements post message, get message, and that's all you need. So, but now, because this is going to be a native DLL, it needs a little bit of decoration. Managed libraries export everything by default. That's true of C++, CLI, C#, Java, shared libraries in Linux. They all export everything. But native code in Windows doesn't. It exports by default nothing and imports nothing. You have to tell it, here's what I want you to export, and on the other end you've got to tell it, here's what I want to import. For example, there's some code that may use Office. The Office suite is huge. It's written in C++, by the way. It's huge. And my application only needs this little tiny part. So I'm not going to go and import all of that Office stuff. I'm going to import this little tiny thing. So I'm going to tell it what I'm going to import. And this was all done. It was written this way, designed this way to keep the sizes small, So what you need to do is you need to declare in the DLL, you need to declare, here's anything decorated with DLL decal is a qualifier, declspec DLL export. This is a Microsoft-specific calling sequence on that function. It says that tells the linker to put that function in its link map so others can find it. And if I'm not inside the DLL, so if def in DLL, I declare declspec export. If I haven't defined in DLL, then I define this DLL decl as declspec import. So my client can include this file, and he's going to import this definition. My DLL is going to export this definition. And what's this definition? Nothing but a COM factory that uses ICOM create function, that ICOM create that we just looked at. That's what it calls. So this library wrapper is nothing but a mechanism to provide those imports and export specifications. That's all it's doing. No real functionality. Just supplying those import-export specifications. Okay. So, and let's take, just for fun, let's take a quick look at COM. So here's com.h. Here's the real COM. Notice now, so I made two changes to COM since you saw it last. I am now deriving from ICOM, and down below COM, I've implemented ICOM's create. ICOM has to see my COM declaration, class declaration, before it can call new. Otherwise, it won't compile. But because it's down below that declaration, so this is all in com. This is inline in com.h. Okay. So I normally don't put as much of stuff in as inlines as I have here. In the class, it makes it a little easier if I declare the class and right below it, inline, 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 inline. So it's, not a bunch of jumping back and forth between files, and, I think it's a little easier to understand. So I've done that a little more than I do for myself when I'm just writing the code myself. But anyway, so that's that. So project 3, if you're not fairly comfortable with what's going on, you should look at it. Do you need to understand every little implementation detail? Nope. Nope. But you need to understand the interface and basically the structure of the messages and what happens when stuff flows around. You need to understand this because do you need to change it? Probably not, but you might have to. I won't say. Depends on what you do. But I think it's very likely you won't have to change a line of code in that. Just use it. So the way this is worked now, this all is built as a DLL that gets wrapped in the COM library wrapper. This guy is implemented as a DLL that loads this DLL. He has a reference to this DLL. And this guy, I haven't yet loaded this, okay, because I haven't started the COM yet, the communication channel. But my next step is, now this guy, simply by calling functions here, this guy will make a reference to this DLL, and then he'll just start calling functions, and it'll load up at load time, and it'll all work. So there's one executable and two DLLs. DLL for this guy, DLL for this guy, and an executable. This DLL is wrapped in the wrapper just to provide those exports and imports. If I didn't wrap it in that wrapper, this would all compile, this would all, that would build, but my linker would come back and say, I don't recognize post message. I don't recognize get message. I don't recognize message. Okay, so I got to export that stuff. So I'm exporting the interface. So, you know, here is, if you look at the server prototype, at its references, message passing, utilities, message sockets, file system. If you look at Translator, so here's Translator. What is Translator's references? As COM lib wrapper, okay? You see message and COM lib wrapper. You don't see COM because COM has to be hidden from him. He can deal with message because message is nothing but strings. And C++ CLI understands what a native string is. So he perfectly is capable of dealing with message, but he can't deal with COM because COM has a blocking queue, which has a critical section of mutexes, for example, and it has sockets. And C++ CLI won't ever know what a socket is, won't ever know what a condition variable is, won't ever know what a mutex is, unless we wrap them. And in fact, that's what the .NET framework does, is it wraps them. So if you wanted to go and rebuild all of that COM in managed code, you could, but you don't need to. Now, one last parting thing. The requirement says HTTP style message, and somebody looked through the code. Instead of grabbing his code from the Project 3 Help Spring 18, looked through the code and said, oh, here's CPP HTTP client and server. That's what we're going to use. Posted on Piazza. Is this what you want to use? And I said, no. What's that CPP HTTP client and server all about? So HTTP is a synchronous, send a message, wait for a response, and it has specific commands, get, put, post, delete, header, you know. And that code specifically sets all that up. It's not quite done yet. But why do that? Because it'd be really nice if there was some way directly in C++ to get this nice markup and event handling without doing managed code and C++ and translator code. And there is a way. Let's suppose that I build a little C++ HTTP server. I'm not building IIS, I'm not building Apache, I'm just building a server that knows how to receive messages and do something. Now I can take Chrome and talk to that server. So my server sends a HTML5 page, which is the interface I want to use with buttons and stuff. I click a button and out comes an AJAX call into my C++ tiny HTTP server, and that server goes ping, ping to the system, says, go do this thing, go do this thing. So we could take all of this and replace it with a HTTP server, C++, CPP HTTP server, and Chrome. And life would be sweet. But I haven't finished C++. I was hoping that I would have it all done and maybe even use it this semester instead of using that, but I didn't get there. Okay. Surprise, surprise. That was priority 2, and I haven't gotten to priority 2 things in the last 5 years. So, but this summer, I expect I will probably do this summer. I will get that working, and I will have a something closer to a full-up repository, something that comes pretty close to matching what your Project 4 requirements are, but using Chrome and my tiny web server. Just for fun. Okay. After you've written enough code, doing things for fun gets a little strange. He's writing code for fun? Yeah. So now, there's quite a bit of stuff here, okay? Quite a bit of stuff here to get your arms around. You think, oh, yeah, it all sounds okay. It seems to make sense when you say it, but when I look at it, I'm dead in the water. At 5 o'clock, so tomorrow or Thursday, I'll talk about this again a little more. So in the meantime, you can look at my code. Understand that it's a work in progress. It doesn't have a bunch of comments, you know, and blah, blah, blah. In fact, probably it would be best just to wait until I post the final thing I'm going to do, maybe some late tomorrow afternoon or something. Take a look at it. We'll talk about it in class. And then Friday morning help session, we'll continue talking about Project 3 and whatever questions you want to ask about this stuff. And at 5 o'clock, Amar and these handsome guys sitting over here in the corner are going to be in this room. Maybe Jinian isn't. Are you out of town, Jinian? Yeah. Okay. But Pranjal and Nikhail will be in this room, and Amar will be in this room. And there'll be little groups, and you know, and you can talk about Amar's demo, and you can talk about my demo. They will have looked at my demo by that time. You know, I just put it up this late last night, so they haven't looked at it yet. And again, probably you guys might just want to wait until, you know, Wednesday afternoon. I'll send you an email when I post as much as I'm going to do for this week, just so you can take a look at it and help people with it a little bit. You know, these guys built something not too far removed from what we're talking about last year, and so, you know, they're really comfortable with all this stuff. And so that's the game plan. All right? So the good news is that's a game plan. The bad news is that's the game plan. Okay. Any questions before we break? I'm ready to break. So if you will, I will hold at 2 o'clock my normal office hours, and on Thursday class, of course, and on Friday, 9 o'clock, help session. There'll be 2 waves. I'm sure there'll be tons of questions, so I'm going to do 2 waves at 9 o'clock, starting at 9 o'clock. I would really appreciate it if you wouldn't come knock, 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 knock at my door today. Other than, you're welcome to come up from 2 to 3. But please don't come knock, 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 knock at my door, because I'm going to be 7 layers down, starting up my communication channel and getting a few messages to flow. So, all righty. See you all then.
哦，我刚想花腰子，这没有发啊，
上回有。
好像有。还是感觉还是不能靠。完全不了。去哪？你们去哪？去哪？等校车好。啊，你没看上？没看。懒得看镜子。在我前面的这个。我现在在中国翻译成什么样的人？就要突然这个量化研究。
第一次。
啊，不知道这啥。
第二次区分路。第三次是当堂的那个是吧？哦，好像当堂的那个大概差距。不走。这块上厕所。
七百还没交呢。没有。第二个同学说不让吃，我也应该也问不大，我迟交了。我还是会交。在这边了吧？到地找地儿睡一觉。
我准备小说，你还说为什么我们要这么早进？因为有事。
这次要写。不是我那扣的再补充。太快了，这也在那个 Visual Studio 里。是不是这次你不需要涉及到任何？下一次就是你在 GUI 里头，然后首先你说我想 browse 一下 CPP。是一个分。
没有。
对。用那个 thread。对，把那个都实现了。像 Shim 它 server 不就是 server 不需要用到，理论上是。
发现再来抓绒图，为啥要穿上了？对啊，人家怕把人家东西找上。 让我提。堂会审这也差不多，哪有每天把错误挂在嘴边的训？这样下去孩子怎么成才啊？还在不在书房里混了？这是威胁我，不是威胁，这是永生的控诉。这包还真的
How are you?
Good.
Good. You seem happy. No JK Lee homework.